In this video, we want to replicate the standard Z tables or the cumulative probabilities for a standardized normal distribution in Microsoft Excel. This is the table that we want to replicate in Microsoft Excel. This table gives the cumulative probabilities from minus infinity to specific value of Z. For example, suppose you want to calculate the cumulative probabilities for Z is equal to 1.05. You have the left column where the Z values are given, and then basically look in this particular row where Z is equal to 1.0, and you have to look for in this column. So we know then the value is basically 0.8531. This is or 85.31. It essentially means that the area under the probability curve from minus infinity up to the point where Z is equal to 1.05 is 85.31% or 0.8531. We are going to replicate this entire table in Microsoft Excel now. So now let's replicate the standard Z tables in Excel. So let me type Z here and 0 goes here and then 0.1. Excel has this beautiful thing called as autofill. So if you look at the increment, just take your cursor to the bottom right after selecting both the cells. It will turn into a dark cursor, and that's the time to drag to autofill. So I'm going to autofill it up to the point of 6, and now the Excel has autofilled the Z value. Similarly, I'm going to type it on the top row and then select both, take it to the bottom right of the cell and just drag it. So now we have the top values. Now we need to fill up the formulas to compute the probabilities. There are two formulas in Excel, norm.dist. Another formula is norm.s.dist. Basically, these formulas are the same. I'm going to show you the usage of both. So let's click on the formula wizard. Let's look for norm.dist and just double click it here to activate the formula wizard. It's asking for the value of X, which will be this cell plus the cell in row 2. And then we know for a standard distribution, mean is always equal to 0 and a standard deviation is equal to 1. Cumulative probabilities, yes, we want it, because in tables it was calculated from minus infinity up to the point where Z lies, and then we press OK, and this is the value that we get. Now we want to drag this formula all the way to the right and to the bottom as well. So we need to affix the sign with $sign so that the relative positioning of Excel formula is retained. So I'm going to activate the formula again. Now you will quickly realize that the column C never changes. So the letter C, as I drag the formula, should not change. So a dollar should come before C. And then I also know that the row 2 will never change as I drag the formula. So the 2 here also should be fixed with $. And now we are ready to actually drag the formula. And then I can. So here is the table that we have generated. And if you now, what I'm going to do is I'm going to format it a little bit so that it looks like the table that we saw earlier. So the first formatting command is you can go to view, make the grid lines disappear, and then what you can do is select the top row, make it bold, and then provide it in the top border and make the decimal across at all the places. Similarly, make the decimals here equivalent, and let's have a right border here, and these are my cumulative probabilities. So enter it using this command, make a font go a little larger. So this is what my standard distribution table actually looks like. Now we use the formula norm.dist, but we could have as well used the formula norm.s.dist. So I'm going to remove this and I'm going to show you how we can use the formula norm.s.dist. So again, go here. This time I'm going to choose the norm.s.dist, and you'll see earlier it required 4 arguments. Here it requires only 2 arguments. The simple reason is that this is the normal standard distribution. So Excel already knows that mu is equal to 0 and sigma is equal to 1, which is why it is not asking. So only 2 arguments. This is far more simpler. Again, I can type this plus this value, quickly fix the $sign before C, and then $sign before 2, and of course we want cumulative. And if you drag it, again we'll get the same values, but this time using the formula of norm.s.dist. And if you recall earlier, I've shown you the value of z is equal to 1.05. So this value can be identified by, we know that we have to look at the intersection of where z is equal to 1 and where the column is 0.05. So, and this particular column, this value is actually 8531. 0.8531 or 85.3%, which is the value that we saw earlier. So this is how to actually compute the cumulative probabilities using Excel. Now there is a left hand side to it where the z values are negative. So there also the formula remains the same. I have already typed in the values here. The only difference is that in the formula of norm.s.dist, if you use it, just make sure that it is the minus sign here, because we want -6 -0. Because minus sign is already fixed here. Otherwise, there is no other difference.
With this, we have been able to successfully replicate the standard Z tables in Microsoft Excel. Just remember that the standard normal distribution will always have a mean of 0 and a standard deviation equal to 1. The formula that you are seeing on the slide on the left hand side is basically the probability density function. We want the cumulative values where the Z actually varies from -infinity up to a specific value.
Thank you.